Right, hey, what's up, guys? Today the lesson is gonna be matrices, section 9, number 9 in the CXC syllabus, right? You can look up in the syllabus and you'll see that this is the learning objective for section 9, number 9, right? So it says evaluate the determinant of a 2 by 2 matrix. Cool. So, all right, so we're basically gonna define what the determinant is, okay? So let's do that right now. Okay, so the definition. Let's define a matrix here. Let's call it A, right? So the matrix is A, B, C, and D, right? Right, this is the matrix. The determinant, right? So we're gonna put DET for short. The determinant of A is equal to AD minus BC. Okay, so this is the definition, right? And let's kind of see what's going on here. Basically, you multiply the main diagonal, right? So you multiply A by D, cool. Then you subtract it by the other diagonal, which is B by C, cool. Simple, a very simple thing to me, right? So you should get AD minus BC, right? This is the determinant of this 2 by 2 matrix, cool. All right, not too hard. This is pretty much a definition here. Let me just draw. Let me try to put a square around this. Cool. So we can show you what the definition is. All right, not too bad. Okay, so that's pretty much the definition of the determinant. Cool. So let's do an example now, right? Let's clear this. Let's clear the screen here, and let's do an example. Let's do a real life example. I think it's always good to do 3 examples, right? It's always good to try 3 times, sometimes more than 3 times if you can. All right, so let's say we'll have A is equal to, all right, 1, 2, 3, 4. I think that's pretty simple, right? Pretty easy to find. So we need to find, and the question says find, ooh, yep, find the determinant, all right, of A. Cool. That's the question. Simple, easy question here. All right, so I'm gonna go based on the definition, right? We already know that the determinant of A is equal to what? AD minus BC based on where AD, D, oh, whoa. Based on where AD, B, and C were in the last example, AD, AB, CD, right? Cool. But in this example, right, 1 is A, right? Cool. B is 2, C is 3, and D is 4. Cool. So that's all we're gonna have to do for this. So the determinant of A is, we're gonna put the one where the A is multiplied by the D in the example, which is 4, minus, what's B? Yeah, B is 2, right? So it's 2 by C, which is 3. Okay, cool. So the determinant of A is equal to 4 minus 6. When we multiply 1 by 4, we get 4, and 2 by 3, we get 6, right? Negative 6. So the determinant of A is equal to negative 2, right? Pretty easy, not bad, right? Not bad at all. Not bad, right? Pretty simple. I don't think this is too hard. Let's clear it and try another example, right? Okay, so in this case, we're not even gonna write the, no, let's not use A again. In this case, we're not even gonna write the uh, formula there. We're just gonna do it because we already know what it is in this case, right? P is equal to 4, 3, 2, 1. Cool. And we're gonna find the determinant of P, right? All right, so let's find the determinant of P in this case. It's gonna be 4 times 1 minus 3 times 2. You're gonna end up with the same thing, right? Even though it's different. Remember the other one was 1, 2, 3, 4. But because the diagonals are the same, you're gonna end up with the same answer here. 4 minus 6, which is equal to negative 2, right? All right, so that's the determinant of P. Pretty simple. Yep, pretty simple in my opinion. Okay, right, so that's the determinant of P minus 2, just like the last example. Okay, so maybe we need to get more creative now, right? Because we can't be using the same example, right? So let's use something else. Let's use, all right, it's 3, 7, 2, and 1. Yeah, I think that's a good example. This is going to be different. So let's find the determinant of C in this case. All right, it's going to be 3 times 1. You multiply the main diagonal, right? Subtracted by the multiplication of the other diagonal. So it's 7 times 2. And you're going to get what? 3 minus 14. Wow, we're going to get something really negative in this case, man. So we're going to get negative 11. Wow. Really negative. But it's still right though, right? That's the determinant of C, negative 11. All right, so let's do one last example. Let's do one that will end up positive. I said 3 examples, but just work with me. We're gonna do 4. We're gonna do 4 in this case. Cool. So let's erase that last example here. Let's say E is equal to 7, 3, 2, and what? 2 and 6. I think that's a good example. All right, so let's find the determinant of E in this case. So the determinant of E is you multiply the main diagonal, right? 7 times 3 minus, when you multiply the other diagonal, you get 6 times 2, right? Okay, so let's work that out. We should get 7 times 3 is 21, right? And 6 times 2 is 12. Cool. So 21 minus 12, that should be 9, right? So that's the answer. Cool. All right. That's the determinant of E. Determinant of E is equal to 9. All right, not too bad, right? Okay, guys, so I also forgot to show you another notation for the determinant. This is actually the better way to write it in terms of the symbol, how it looks. So you can write the determinant this way, right? So let's just give an example here, right? Let's just clear it. We have a matrix A, which is equal to 1, 9, 3, 2. Cool. And we want to find the determinant. Instead of writing DETA like I did before, you can actually just write A with the modulo symbol, right? Which is basically 2 lines around it. And this is the same thing as the determinant. Okay? All right, so it's the same thing, man. Same thing, right? Awesome, great. Now, let's just remove that there, and let's find the determinant of this matrix in the example. So, to find the determinant, we'll multiply the main diagonal, which is 1 times 9, minus the other diagonal, which is 3 times 2, right? So we're going to get 9 minus 6 is equal to the determinant, right? So the determinant is equal to 3. Cool. All right, so essentially you can write the symbol for the determinant in 2 ways. You can write it this way, or you can write what I wrote earlier, which is DETA. But genuinely, I prefer this. It looks a lot neater, right? So guys, remember to write this for the determinant symbol. It's the much preferred symbol in my opinion. And thank you so much for your time, guys. Have a wonderful day. Remember, do your best and God will do the rest. And see you in the next lecture.